Guys, welcome again. Welcome back. We have gone through multiple different core concepts of the Docker, right? But for me, this class is very important, very critical. First of all, I would like to welcome you guys again at the live training on this YouTube channel under the IIC Rise, right? So those guys who already been with me from long, right? So they know in the IIC Rise we keep on doing multiple different, not that training per topic wise, but we we pick one tool and one technology, and we'll try to go as much as deep dive as we can, right? So for last couple of week we have done lots of thing in the Docker, but there's one more topic I think that is very critical in the Docker world and that you should know in the Docker, that is DockerFile, right? So my plan, guys, for today would be purely to talk on one of the main core concepts of the Docker, that is DockerFile, right? So before we go, I will just like to just link the context what exactly we would like to do. So almost everybody know there's one public repository available called Docker Hub, right? And if you search here, there's lots of images available. For example, if you search for CentOS or if you search for Ubuntu. Okay. so the, so there is a lot of images available over here, right? But you guys know, these images you can download, you can use, but my main topic for today is how we can create our own custom images, whatever, exactly the same way that is available in the Docker Hub. Okay, so my plan for today is how we can create our own Docker images. And when I say on, it means how we can create our own custom image. Okay, and guys, if you know how to create the own image, right, you can do anything in the Docker world, right? Any kind of deployments, any kind of a configuration, any kind of setup you can achieve in the Docker. But if you would like to create our own image in the Docker, all right, your own custom image on the Docker, there's two way available. One way you already know, because in the last session we have covered using a command called commit. So this is the one of the typical way you can use to create your own image. But in this option we have very limited features available, so you can't do some advanced thing by using docker commit command. So this is not the perfect way or the best way to create our own image. Okay, the best way to create our own image, or to create I'm so sorry, guys, to create your own personal customize your own name image, right, and the Docker using some scripting language. So Docker has their own scripting language. Docker has their own personal keyword. We can use the keyword of the Docker, we can use the language of the Docker, and we using this we can customize, we can create our own image. Okay, and this topic, right, where we can use the keyword of the Docker or we can use the Docker scripting language, are known as Dockerfile. So Dockerfile is one of the second way. This is the first way, right, that has very limited options available. But this way we can create any kind of customized image or whatever you feel like. Okay, so main topic for today is, and that is one of the core topic in the Docker world, and it's so critical. So if you in the future, if you would like to use Docker, maybe in the Kubernetes, if you want to use to like Docker in the Jenkins, this one of the CI/CD tool, or maybe you want to use Docker in OpenShift. Okay, so any of the environment, right, wherever you would like to use Docker, or maybe Docker kind of Docker kind of setup, right, or the container technologies, right? Normally we use in Kubernetes, normally we use Swarm, normally we use in OpenShift, or maybe some kind of CI/CD tool. So any of the environment, okay, if you would like to use Docker, man, because technically in the real world we use Docker in these tools also, or with these tools only, right? Then you have to create your own image, and for creating the image, these tools normally they use Docker file concept behind the scene to create the Docker image. So what I mean by this, we will link soon, but I'm just trying to emphasize the Docker or the container is the main uh, core technology in today's world, right? But but normally we don't use Docker directly. Right, in the last session I also discussed we use Docker either with Kubernetes or Open Shift, or maybe some kind of cloud services, maybe Jenkins, maybe Mesos Marathon. There's tons of tool available, right? But whatever tool you use, whatever technology you use, right, normally and most of the time we have to create our own images, right? Because every image has the own use case, right? Because maybe you don't want to use CentOS, you have your own operating system, you have your own kind of environment. So Dockerfile is the one who will help you to make your image very faster and create the image depend what is your requirement, right? So so my main point and my main topic here is today is the Dockerfile. But before I start the today's topic, okay, even though I'll try to talk lots of about the Docker file. Anybody have heard about a Docker file? So in the Docker file we have a concept called environmental keyword, we have a concept called CMD keyword, we have a concept called entry point. So almost all the main keywords or topic in the Docker file we are gonna discuss today. But I would like to start the thing from very zero, because for this class there is a very small prerequisite. You should know something about the Docker, or maybe if you go through my last video of the Docker, that is a prerequisite. But maybe some of the guys might be a little bit new in the Docker, right? So I'll try to first link what exactly we have to do, so everybody can understood what exactly we are going to do. But again, I'm repeating, today's class is very important in any of the environment you want to work on, right? Knowing these logic is very critical, right? So so let me start from here. Okay, okay, let me start from very zero. If you would like to install any operating system, okay, you normally need DVD or maybe some ISO file or some ISO images, right? We use these guys to install the operating system. But if you again understood what is the use of any operating system in the world, there is only one use case for of any operating system in the world, is to run some program may be Firefox, program may be Python, maybe Java, program may be your pen software, program may be your VLC player, right? This is the only use case of any operating system. This is the reason we need operating system. Okay, now it means right, if you install any operating system, two things you should know. First, we need some kind of image or DVD or bootable DVD to install the operating system. This is for installation. And after the install, right, we go inside the OS and install some program. And after install the program, we'll run it, we execute this so that we can interact and use our program. Okay, so if you talk about my system, so in my system I have VirtualBox. So I had some ISO image with me. I use that image, and from that image I install one operating system. But this is not the end actually. After I install, I boot this operating system, and after I boot, I go inside and depend what exactly I want to do in this OS. I want to do something machine learning, I want to do something in Python or Java, or databases. Accordingly, I installed one program inside this OS. So technically, it means you can say only OS is not enough. OS plus program you need. So this complete set you can give the name called environment. So you need an environment if you want to do something. Now it means for getting the environment, either you go for this typical step, right, to use DVD or some ISO file, or what can you do? Same environment you can create. Again, you can create one operating system. You install one operating system, and inside the operating system, you run your program or install a program. Let's say maybe you guys want to do something Python, so install one Python interpreter, right? So that you can run the Python code. It means again you need an environment for what? For running the Python code. But here, right here, if somebody give you the environment within a second, within a second, right? So that would be always preferable, right? And this is the example of the Docker. So Docker also have their own image. That's called Docker image. So from the Docker image, I can install or configure any of the environment, and normally it set up the complete environment, and roughly within a second. Within a second. So till here everybody know who go through my last classes, right? But the most important thing is, guys, right, whatever you get in this operating system, whatever you get as a program in this operating system is come from the image. It means, right, whatever image we use, if in my image, if you don't have a Python program, it won't come here. In the image, if you don't have a Java or machine learning program, or maybe some other program, right, for backup or something like this, right? So whatever you have in this image, right, it will, that image install and set up the environment for you. It will install the OS for you, it will set up the environment for you. It means final OS plus the final program list, all the program, all the software there's in this OS, right? This become a complete environment, come from the image. Okay, it means if you want some kind of custom environment, maybe you have some little bit different requirement. Maybe you want one operating system, right? If you want one operating system, right, and in this operating system, what you want, as soon as my operating system installed, inside this operating system I would like to do some machine learning programming, or maybe I would like to do some kind of gaming, or maybe I would like to write some kind of Java code. So what I need OS. Inside this OS, I need some machine learning libraries or Python or Java. So this is my requirement. This is my environment I need. So I can write my code on the top of these guys, and they will run for me. So for running the code, obviously we need some kind of compiler or the interpreter. We need some kind of libraries, or we want OS. But who will give this environment? Now there's two choices. Either you create, for example, if you go for this particular VMs. So first we install the VM from Red Hat or CentOS or Ubuntu or Windows. Okay, that is only the operating system. And after operating system, you go inside, you install your own kind of software, database, MySQL software, or Python, Java. So it take a lot of time. But maybe either you create your environment, or maybe this is the only, not only once you want, right? Maybe you have to set up this environment hundreds of times, right? Different code you have. You have to test different code for multiple times. Okay, so there's two choices. Either install this OS, again go inside, set up the environment, again install one more time, install the OS, again set up the environment. Or what can I do, because I know this environment, this complete environment come from the image. So what can I do? I can create my own custom image. Okay, so what happened, because this is my custom image, and I will write inside the image whatever I want. So I will write whenever this, from this image, when I launch any operating system. It doesn't matter which technology you are using. You're using cloud computing, you are using Docker, you are using virtualization. It depend, right? Is a concept for in all the technologies. Okay, so if I can create my own custom image, right? And from this custom image, if I launch my operating system or I launch my environment, what I'll get, whatever we have in the image. So now the matter is, right, what exactly you would like to put in the image. So that's what my topic is today, how we can create our own custom image. Inside the custom image, I'll say whenever this custom image launch the OS, I require my base operating system, let's say maybe Ubuntu or maybe CentOS, maybe Red Hat. And inside this OS, I want my one program or library or interpreter to be there. Or maybe I also want some code also to be there, so I can directly test it. So depend all those things, all those stacks you can put together in one box, and this box is called image. And because this is the image, right, because this is the image, so from one image you can launch as many as operating system you want. So you don't have to again and again install it, you don't have to again go inside, you don't have to again and again go and set up your environment. You have to just create your image only once. And now from this image, how many OS you want to launch, you can launch it. Okay, but if this image is created with a technology called Docker, so extra thing you'll get in this image is, right, after this image created using Docker or any of the container technology, right, launching the OS or launching this environment won't take a lot of time. Just in 1 second, your complete environment launched. Okay, and this will be great, right? So if you have if you would like to test some code, or maybe in a day you want to create this environment hundreds of times, all right, so you don't have to wait to install this OS, then go inside, then configure, install. It take a lot of time, right? So today's we are guys living the world of agile world, right? We are living the world of DevOps world. In this world, how faster you launch the environment, how much time you can save, that matters a lot if you really would like to succeed in this today's competition world, right? So that's what I'm talking about here. So finally guys, I'm just trying to try to explain you why we need to create a custom image. Okay, and creating the image is a one time effort. Now from this image, how many OS you want to launch, you can launch it. And point is how to create your own custom image. There's two way. One, the typical way in the Docker we have the command called commit. It is very simple way, but here this command is doesn't give you so much flexibility. You can't customize a lot. But other way is scripting way, right? Here I'm going to use a concept called DockerFile. So this is my today's topic. So today's topic is how to create our own custom image in Docker using DockerFile. And one more small information I would like to tell you here is, okay, by this concept I can create my own image. Typically this image is known as Docker image, but it doesn't means you can use this image only for Docker, because technically Docker is just a tool working on a technology called containerization. So if you go through my last initial videos, I talked about containerization is a name of the technology and Docker is just one of the product. But there's lots of other products also available in the market, like Podman is here, like Cryo is also here, like Rocket is also here. There are lots of product available who work in this technology. So technically, if you create a Docker image, this image is compatible with almost all of these guys. So after you create the image, now whatever technology you want to use, either Docker technology or Podman or Cryo, these image support there. Okay, so maybe this image is known as Docker image, but it can support in Podman, it can support in other technology also. So that is a reason, rather than you can give the name this guy as a Docker image, you can also give the name this is called my container image. Container or container technology image you can use. But Docker has become so much standard in the market. In normally we always use this term. This is my Docker image. Okay, so it means creating the image or creating your own own image, right? We use Dockerfile, but after image created, now this image you want to use in any of the technologies, you can use it. Okay, but today's topic is Dockerfile. Let's me focus on those topics, right? So before I'll start this topic, how to uh, create your own image, I would like to show you some very basics demo that you guys already know. So right now I am into my Red Hat version 8 operating system. This is a command line terminal. In my system, my Docker program is running. How can I confirm? We can use this command to confirm my Docker is running. So it is active and running. Okay, and I would like to check how many images I already have. So I have already downloaded the image from Docker Hub or maybe some from other locations. So this is the command you can use. So I have a lot of images with me. Okay, and one of the images that I already downloaded in my last class is called CentOS. If somebody doesn't have this image, how to download, you guys also know, Docker pull and CentOS. You can use this command. It will download the CentOS image from the internet. CentOS is like a operating system, like a Red Hat. Okay, so it is just operating system. Let me share this command to you. So I already have. And what you do from this image, you launch the operating system. So before I launch, let me check, does I have any operating system running? No. Or maybe you can use have an A. It show you all the OS that is running or is stopped in the background. So I don't have any operating system running or the stop. It's a new fresh clean environment. So this is my base Red Hat system, and on the top of Red Hat I am going to launch a new operating system, and this is the command you know. And for launching I use IT or DIT, IT. Okay, and I would like to launch the new operating system with the name called OS1. Okay, and my OS will be launched from this image. So technically I'm going to use this image to launch or install one new operating system. Okay, so that's what I'm doing here. So one click, my OS installed, the boot and launch, and I will be inside this OS. So this is the new OS. You can see I was in the Red Hat. Now I'm into my different operating system known as CentOS Linux. Okay, but right now, guys, in this OS, this is just a OS. This is just a operating system. If you want to run some program, let's say you want to run a Python code. So for Python code, what you need? You need a Python interpreter. So do you have any Python interpreter here? No, I don't have. It means inside this OS, if even though you can write the Python code, but but you don't have a Python interpreter, you can't able to run it. It means there is no use of this operating system for me because I want to run my Python code, or my PHP code, or my Ruby code. Okay, so technically, after you launch your operating system, what you have to do, you have to install. It is something like this. After you install Windows in your laptop, you don't normally use Windows normally, right? If you want to run some Python code, you have to install some Python interpreter. Same thing I have to do here. So I have to install Python. How to install Python? All right. Again, because this is CentOS, CentOS is exactly like Red Hat. So in the Red Hat, we use yum command to install the Python. And here I'm going to use Python 3.6 version. So this is the name of the software I'm going to use. Okay, so this will install Python for you. They will download from the internet and then will install it for you. So technically, finally, what exactly I'm doing from the image that I have. Let me start from here. From this image. So I had the image, and this is the only my base operating system image, CentOS. Okay, and this is only the image, only the operating system that doesn't have any kind of program that normally we use. So we can use the term called is my base image, and from this base image I install my operating system. But only operating system is not useful for me. So what I am doing, on the top of the operating system I am installing some program, or in my case I'm installing Python interpreter. That's what I'm doing. So finally these two guys become my environment. So they are installing for you because they are downloaded from the internet. It waits some seconds and it will install for you. But main thing over here is, guys, after you create the environment, right, what can you do? Just go and write your code, and because you have the Python interpreter, you can run it. Pretty simple, right? But this is what? This is your complete environment, or you can say this is your complete operating system. Let's say this is operating system number one. But maybe you have one more requirement. Again, somebody asks you to launch same environment. So again, you use your base operating system, right? Again, from base operating system, you launch one, or from base image, you launch one operating system. Again, you launch, it takes some time. Then again, you go and install Python. It become new environment, let's say environment number two, one. Okay, so this is second environment come up. Again, you use your other code and run it. Again, maybe sometime. So technically, right? What finally my need is to have this environment OS plus Python. How many time? One time, 10 time, 100 time? I don't know. So rather than you keep on installing the operating system, operating system for base image like CentOS that doesn't have any program like database, PHP, MySQL, web server, Apache, all right? So always you launch your OS from a base image, and after base image, you invest some time, install the software, configure the software, and then finally your environment create. Either you do this way, or what can you do, right? You can create your own custom image, custom image rather than use the base image. Custom image, right? What's a custom image will contain, right, what we need, right? My custom image contain this OS data plus the Python interpreter or the database interpreter, whatever you need, database program. So these two guys I club together, okay, and packed in one packet, and this packet is called image. Or because this is image is like a DVD, bootable DVD. Now from this image, because this is image I have created, so I can put whatever I put inside. Okay, now from this image, I can launch my operating system, or I can launch my environment. And now because this is image and this image of the Docker, so launching the environment may 1, 2, 3, 400. Won't take a lot of time. Within a second, I can launch it. Okay, and all the environment I can provide to multiple developers. All the developers have their own personal environment, personal setup. They can work on it. If they want to destroy it, they can destroy it. I can give within a second. So very faster, because if we are launching this environment from the from a custom image, and this custom image we are using Docker technology. Okay, that's what we are doing. So right now my Python installing, they're installing. Okay, but technically the method I use, right, I use this method. This is a pretty typical old method, right? I first use my base OS and then install Python. Okay, the Python install. Now if I run Python 3, I can, if you guys know about Python, you can use this program and just print whatever you want to print, use some code and exit, run the code, all the things you can do. But again, this Python is only there in this OS. This is the OS name. So even though, let me open my new terminal. So you can run docker ps command. So this one new OS, the name I given is OS1. Python is always only available in this OS. In this OS, right? This is the OS name, ID, or the OS name. But if you want to get the same environment, this is like, this is my OS, means this is my environment. You want to get the same environment, you can't get it. Okay, so if you want to get the same environment multiple time, again you have to launch the Docker container CentOS. Again you have to install Python. It take a lot of time. Again the download, the install take a lot of time. Either you do this way, or you can create your own custom image only once. So that's what I'm going to show you. Okay, even though you can use commit command here, but without commit command, how we can do with the Docker file. So let me shut down this OS, exit OS shutdown. So I don't have any OS running. One OS I shut down, so you can see with A. So this OS shut down, exited. But you can start again. You start the OS. You can go inside. You can see the Python, but only in one OS. So one OS is equal to one environment. But from this OS, you can't create one more OS. So for example, we want 10 OS like this, we can't. So every time you have to install the again Python install and do the things. So same step I have to do multiple times, but I don't want. So I want to, because I know I want this environment hundreds of times maybe in the future. Okay, so why not create our own custom image that contain everything, this complete box. So for creating this complete box, we have to use Dockerfile. So let me show you how we can do with the Dockerfile. So for the Dockerfile, you have to write some code. And for writing the code, it is always good practice to create a separate folder. So I'm going to create a separate folder. Let's say my folder name is workspace. Okay, so it is always good practice in the programming world to create a separate folder called workspace. Right? This folder empty. And because what my need is to create my custom image. Okay, but if you would like to create a custom image, you should know what exactly you want. So inside my own personal image or custom image, what I want my base operating system come from Red Hat, Windows, Ubuntu, CentOS. So let's say I pick CentOS Linux. So my base operating system would be CentOS. This is my first need. First need. My second need is inside this OS, I need Python interpreter or Java interpreter or web server. This is my second need. And these two need I plug together, put in the one box, and this box calls CentOS image. So technically, right? So technically, this new image in this new image, right? I want my CentOS would be my base OS. So my OS will come from CentOS. And inside the CentOS, what I want, my CentOS will install the Python program for me or will run the Python program for me. So this is the second thing we want. So guys, this is the exact keyword they have. So Docker file is just one concept of writing the script. And in the Docker file, we have to use some keywords. What you need. So if your need is this first one to use your base OS like CentOS, Linux, or Ubuntu, then the keyword that I'm going to use would be from. From is one of the keyword that we're going to use in this file or in this scripting language. And then on the top of this OS, I want to install Python, Node.js, MongoDB, Hadoop, what do you want, right? So second keyword will be run. So this run will be installed or set up this setup for you. So this all because you have just two needs. So we have to use two keywords. So let me show you. It's pretty simple to do. So what I'm going to do, I'm going to create a new file. So I'm going to use gedit as a text editor. And if you want to create a custom file, you have to use DockerFile. And technically, DockerFile is a file name actually. It's not a topic name. The file name where we write the script is DockerFile. So here, guys, the constraint is if you go for any other language, you can create the file name with any other name, any of the name, right? But in the Docker file, your file name should be same. It should be Dockerfile without a space, right? And where D should be capital. So this is the pre-defined file name. So whatever code you have to write, you write the code in this file only, where D is capital. Okay. So let me run this. Okay. And now in this code, we have to use some keyword. Okay. But the keyword is depend upon your requirement, right? What is your requirement? My requirement is first this one. I want my base OS to be CentOS. So for this, the keyword is from. So from is my keyword. And here I'm adding my base OS to CentOS. That's all. Okay. Now second requirement is inside this OS, I want my Python interpreter or Python's program to be installed. So I want to run this thing. Okay, so my second requirement is to do something. And when you want to do something in this OS, you have to use run keyword. Okay, and what you want? Python to be installed. But who will install the Python CentOS? A yum command. Yum install. So I will ask my yum command, right, to install Python in the CentOS. And those guys who know something about yum command, whenever you yum command, right, it will install the software for you. And yum command normally we use in CentOS or Red Hat or Fedora. But whenever you use yum command, they always ask yes or no. So you have to always press yes. But I don't want they ask me yes or no, so I can press -y. So -y is one keyword. So what happen whenever run keyword will run this command, they won't ask yes or no. They without asking yes or no, they will install the Python for you. That's all, guys. This is the very basic Docker file we have created. So let me close this file and share this code also with you. Okay. So this is scripting. So technically in this folder, I created this file. That's all. So what is this? This is my own custom script for creating my own custom image. And we run this image to create my image. Okay, so we run this code to create my own my own custom image. Okay, and this concept is known as by running this code we will create this custom image, and this running is known as build. So we have to build this code, or we can use the term called run this code. So building is the term we use. So we build this code, and as soon as it build or run, it will create a custom image for me. So that's so simple. You just need to know what exactly you want, right? You just need to know your step. You want this, maybe you want some more thing, keep on adding. Okay, and for this there definitely might be some other keywords also come up. Right? So let me show you how to run. for run, you use command called docker build. And what I want, because this is the my own new image I'm creating, so you can give any name. So let's say I'm going to give my image name to be rise. This is my image name. And guys, you know from my last classes, every image has the own version. So after colon, I just give version 1. So my image name would be rise colon version 1. So this will be my image name. You can give any name, whatever you feel like. Okay. But before I run this, let me show you. I don't have any image with this name. So I don't have any image with the name called rise here. If you see here, I don't have any image. Even though you can search also in the command line, you can use pipe as a one symbol, and you can use grab command to search. Do you have any image with the name called rise? No, I don't have. Otherwise, they show you. Okay, so let me create it. Okay, so I'm going to use docker build, and my new image name is rise. You do you want to give the version? Your choice. I'm going to give version 1 at your choice and not compulsory. And what I want to run this code. But where is my code is in the Docker file, and where the Docker file is in this folder. So my folder name is this one. Okay, so guys, you don't have to give the file name, because normally whenever you run any code, you have to give your file name. But here you don't have to give your file name, because Docker file is a file name that is a predefined name. So Docker build no, we always write the code in this file. So they automatically go to this folder, and this folder, they search for this file name, and where they find this file, they retrieve the code and run for you. So technically that is a reason your code should be in this file only, otherwise they won't run. Right? So let me run this code. So technically I am building my code. I'm building my code, or technically I'm creating my image. So because there's two steps in my code, step 1 and step 2. So what is my first step? This one. So I'm using my base OS to be CentOS. First step done. Second step, in this OS I want my Python interpreter to be there. Okay, so that's what they're doing. So internally, you know what they're doing. They're installing Python again. They're downloading Python from somewhere, and after download, they install for you. It's again for once. Okay, and guys, there is a one small issue, because I don't have Python software. I have a software called Python 3.6. So let me update my code. My 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 software name was not Python. The software that I have in my location or yum is Python 3.6. This is my software name. So let me update my code here with you again. Okay, let me run this code. So this is my new file, and then installing for us. Okay, second step, and after second step, you will have your own new image. So now from onward, this would be your final image. After this image created, what can you do with the image? Simple. From this image, I can launch my operating system. How many? As many as you want. Hundreds and thousands image you can launch. 100,000 OS you can launch. And how much time it consume? 1 second. But what finally you get in this image? You get the complete environment. Which environment? CentOS OS plus Python. Whatever you put inside this image, you get this environment. So maybe in this environment you put some deep learning code, TensorFlow, Keras, maybe big data, Hadoop, Spark, maybe OpenStack, whatever Grafana, Prometheus, right? Oracle database. You have to install once. It might take some time for first time creating the image. That's what it is taking here. Okay, but after the image created, now from this image, within a second, your environment will create. So you can keep on using. You don't have to again and again install it for testing or other things. That's what they are doing here. So finally, it is completed and successfully they create this image. And you want to confirm again, you can use Docker image. You can search with the grab command. Now you can see 14 seconds ago, I have created a new image called Rise with the version v1. Or because this is the new OS you have, okay, you can launch one OS. Okay, so right now I don't have any OS running. So how to launch the OS? You guys know, again, same command, docker it, just give it some name, maybe OS2. Okay, now this time I'm launching the OS not from CentOS, not from Ubuntu, from my own custom image. Okay, so this is the image we have created with the version v1. But I know in this image what I have. Okay, maybe Oracle, maybe it takes maybe one day for me to create this image. But now after image created, I can use this image to launch hundreds of OS within a second. So one click, OS launch. Okay, exactly same. But now this time this image base is OS, base is CentOS Linux, but inside the image I have my own environment. I have my Python. So you don't have to again install the Python. You can see Python is already here. But it's working fine. You can run your code, do the things, whatever you feel like. Okay, so this is the one of the very simplest example to create the image. But logically, let me open one more terminal here. So if you run docker ps, you can see one new OS running, but this OS will launch from my own image. My image name is this one. So I haven't downloaded from Docker pull or from some internet. I have created, we have created our image. Okay, that's what over here we can see. Let me shut down this image. But you have the image, you can create hundreds of OS from this image. Okay, so technically my main intention till now here is to explain you to explain you that uh, depend upon a requirement. All right, if you have this kind of requirement, you can create custom image, and these are the logics we have to use. So logically, guys, I think you understood the use case, but let me show you some more interesting concepts, all right, about this image. So technically, let me show you some more interesting concepts about this process, but let me share this command to you. Okay, so technically, guys, understand one more small thing, right? What our need is, right? uh, you can think in this way, why we want operating system. Okay, maybe I want operating system to run one program. Which program? Some of the program. It won't be possible that you say I need operating system without a program. If without a program you can't do anything in the operating system. Maybe VLC player or window media player, some program you need. Okay, so let's say you want one operating system, and on the top of the operating system you want a program. You want a program. Which program? Let's say you want a Python program. And typically in the technical world, right now you see your laptop. In the laptop, I have Windows, and Windows we have lots of program, because this is my desktop system or this is my personal computer. But in the real world, if you go to server, normally in the server again they have the OS, but in the OS they normally install only one single program. Only one single program, what exactly they need, or one single service. So when I say program or when I say service is the same thing. So we in the real world or in the technical world, we install our operating system, okay, for per service basis or per program basis, either only for Python, either for Java, either for web server, database server, only for one service. Even though you can go for two service, but for due to lots of management reason, a lot of security reason, it is always a good practice, right, to install one OS per program or per service. This is a good practice. Okay, so if you know this, if you understand this good practice, right, so you can think in this way, right? I want one operating system, and this operating system I need for one service or one program. Let's say that program in my case is Python, only for Python. It means because this OS is only meant for Python interpreter or Python program, right? It means, right, it means if anybody who use this OS, okay, what they will do first, they install this OS. This is the first step they do. Then they install Python interpreter. So second step, what they do, they install program. The second step they do, and after they do the second step, then they launch the Python. Then they execute the Python interpreter, because final intention is to use the Python, right? For example, your intention is to use VLC player. So after you install VLC player, what do? You just double click on the VLC player, then VLC player execute. So third step is what? Execute Python. After doing these three steps, now your environment is ready. Now whatever you want is ready. So for example, let's say your OS is Windows. So first install Windows. Then install one program called VLC player. because your intention is to listen and see the video. And third, you execute VLC player. Then you can say, now my environment is ready, my setup is ready. Now I can play the song and I can view the video, all the things. Okay, so because your intention is to use this program, and you can use the program after execute. So what can you do? We can also create one more image, because you know what, the image that we have created in this image, the challenge was when you launch this image. Okay, you get your base operating system, you get the Python install, but after Python install you have to do something manually, right? You have to run the Python 3 command, right, to get the Python. Because we know we create this OS for Python 3, so why have to run Python 3? So what I want, as soon as my launch my OS, automatically Python 3 starts. That's what I want. Or as soon as my OS terminate, Python 3 stops. Right? Or as soon as I stop my Python 3, my OS stops. Right? So it is something like this. You can think in this way. You install this Windows for VLC. So what I want, as soon as my Windows start, VLC player start. Or as soon as my VLC stop, my Windows stops, because I don't want to use my Windows for any other program. Okay, so normally in the real world we use, especially in technical server or production systems, right, or any other servers, we use our OS per program. Here the per program would be Python. So technically this image that I created, right, it give you Python, but technically the third step you have to do manually. But I don't want this. So I want, as soon as I launch my my OS, right, my Python automatically starts. So for this you have to add one more step. It's called execute. And for this, again, if I draw the diagram this way, right? So what I want my base OS would be from CentOS. Inside this OS, I want Python interpreter to be installed. Plus, I want one more thing. I want, as soon as my OS start, as whenever my OS start from this image. In this case, I want my Python software that I already installed. This Python interpreter automatic starts. Start for me, so I can start using it. But without running the Python interpreter, I can't run my code, right? So that's what I want. Okay, so this is my third steps I want. And if you have a requirement, and requirement is, as soon as from the image you launch the OS, and when the OS launch, that time this Python interpreter or VLC player automatically starts. For this, we have one more keyword. For this purpose or for this use case, we have one more keyword called CMD. CMD means command. Which command you want to launch, or which program you want to launch. So this is one of my keyword of DockerFile. So let me show you. So again, in this folder we have this file. Let me update this file. So what I want, I have three steps. I want my CentOS to a base OS. Then I want Python 3.6 is one of the software that is installed. Plus I want after uh, after this image create. Okay, and then somebody use this image. That point in time, right? Automatic, when they launch the new OS from this image, right? Python interpreter automatically launched. That's all. Or Python interpreter means Python 3 command. Whatever command you want to use. Python 3, VLC, whatever command you want to use, Firefox, you can write here. That's all. Okay, let me close this. That's the meaning of the Python CMD keyword. Okay, and now you have to run this code. For this, you have to build. Again, for build, you have to give some name of the image. Either you can give the same image name that you already created, so it will overwrite, or you can create one more version. So your older image also there and newer also there. So whatever you want to use, version 1, version 2, you can use, and this is called versioning. Okay, so new one more image they create for you. And again, from which folder? This folder. So this is the folder where my Docker file located. So go and run it. Okay, so this guys, 3 steps they have done, and very fastly they create this image with this name. Okay, let me share this code to you. Right, and now if you go to Docker images, you can see one more new image come called version 2. So both the image name is same, but version is different. It is, you can think like it's a Windows 7, Windows 10, something like this, right? So in this image, if you launch, it is only have two steps. In this image, you have three steps, right? So whenever you launch this image, it will automatically launch Python for you. So let me show you how to launch the image. Docker run IT. Just give some OS name. Let's say OS 4. Okay, and I'm going to launch from Rise V2. So what do you see, guys? This is what image name, like a bootable DVD. But as soon as I launch the OS from this image, and guys, by the way, in the Docker world, OS is also known as container. So from this image, as soon as I launch my container or the OS, or you can also use the term called environment, all the three things will happen in one go without you have to manually do. Everything will be automated. Okay, so let me show you, right? And one click, you can see Python interpreter come up, right? See here. So you know what? This is the Python interpreter running inside this OS, right? So this OS has CentOS. Inside CentOS, Python installed, and as soon as I launch, when I launch, that time they see this keyword. Does this keyword available? Yes. So they internally run this Python 3 command and they launch it for you. Okay, so if I open new terminal, you can see this OS 4 OS is running right now. So if I run the Docker PS, you can see OS 4 is running. And you can also see the command here. Which command they're running? Python 3 behind the scene. Which image they're using? V2. But as soon as I come out from the Python, okay, and understand one thing, guys, I'm not coming from the OS. I'm just coming out from a Python interpreter. But as soon as I coming from the Python interpreter, my OS will shut off. You can see I am coming my base Red Hat. So even though you can check from here, you also shut off. Because there's no need, right? I don't want to do anything else, right? Because my OS is only meant for Python or database. So as soon as my database stop, my web server stop, my Python stop, I don't want my OS. So as soon as the Python stops, your OS also stops. So this is a great way to manage the thing, right? So technically our intention is, you know what, we should know what our exact need, right? If our exact need is to just use VLC player, just use Python web server, right? And I want, as soon as my OS start, web server start, I want my OS shut off, web server shut off, right? So in that context, why you do manual, right? As soon as the OS start the Python. As soon as the OS stop, as soon as the Python stop the OS. So that's what we can control with Dockerfile. This thing would be very harder to control with commit commands. So this kind of customization we can't do. We can't do with the commit command. Commit command also we can use. From last lecture I show you how to create your own image. But these kind of custom things, customization that I'm doing right now, that you can't do from the commit command. Here we have to use some scripting keywords, scripting keyword, and the keyword I'm using for Dockerfile, from the Dockerfile. Okay, so this is one great example here. Even though there was some more great example you can do. For example, maybe you have a requirement. So what you have your own image. Okay, and what image will do? As soon as from this image I launch my OS, and this OS is only meant for to doing the backup. Okay, so auto backup starts, and as soon as the backup complete, my program stop. My OS gonna stop. All right. Or maybe you have an OS that is meant for downloading something. So as soon as the OS start, they start downloading, and as the downloading stop, your program for downloading stops, and after programming stop, your OS automatically stops. Okay, maybe you have one OS just for testing. So in some DevOps world, we have some concept called testing. So as soon as my my OS start doing some testing, unit testing, integration testing, some acceptance testing, multiple testing, and as soon as testing complete, my OS stop. Okay, because I don't want, right? I don't want to use my OS for that after download done. I don't want to use my OS after backup done. But whenever my backup start, whenever I need a backup, I launch the OS, right? And you guys know about the great thing about the Docker is whenever you launch the OS, right, it is very quick within a second. This is one great thing. Whenever you launch the OS, it is isolated. means you get a security. This is one of the great thing. So I want my OS that is dedicated for the backup, or due to any reason if my backup OS hack, it won't impact other system. Okay, so 1 second they launch, they provide security isolation. So though in the last classes I discussed those things already with you, I just want to try to recall, because a lot of guys think, right, if you want to do backup, run the command. If you want to do download, run the command. I say no. Okay, maybe I can do the backup with the command, I can download with the command, but due to any reason if the command hack, they will hack also other command in the same OS. But in this OS, because this one OS only for backup, due to any reason backup command hack or this OS hack, it won't impact other command, it won't impact other environment. So everything is isolated. So this is one of the great benefit, right? Other benefit also we have, that in the last classes we discussed. All right. So that's what I'm just trying to link it. So let me create one more example here. That is very interesting example, and example we keep on talking from the last class. So I am going to create one more image, one more image, one image, again using the Docker file. And in this example, I'm going to show you some more interesting keywords or some more interesting concepts, right? So let me show you one example. A very familiar example. You have seen the same example in my last classes also. Okay. So example is about web server. Okay. So what I want to set up the web server environment. Okay, web server environment. So let me show you the two way. The first way is, for example, if you have just a base image CentOS, from this image, okay, from this image, if you launch the OS, if you launch the OS, and after launching the OS, right, and if you want in this OS to host your website, what do you have to do? First step is to launch the OS. Then second step, you have to set up web server. Okay. Third step, right, you have to get the copy of the web pages, right, and copy here. So whatever web pages you have to copy here or deploy here, third page. So all the thing you have to do manually. And then finally you can say now my environment is ready. Now this OS has this OS will what the IP of this OS I'll just provide to my client. They can connect and see the site, but again manually. But we know, because this is a very common thing, and every time we use this is a very common thing, right? Every time I want to launch my OS, to launch my web server, to copy my thing. So why keep on doing every time, right? So why can't I create my own custom image for this? So let me show you with the practical, pretty straightforward. So what I'm doing, I'm just trying to show you first manually. Okay, so let's say I have let's before this let me clean my environment. So I have a lot of image OS running. So let me terminate all the OS. So from the last class I show you one command to terminate all the OS in one single go. The docker rm f forcefully, then percentage docker ps -anq. In my last class I explained you this command meaning. So those guys who have gone through my class, they know this command. But technically this command will clean all the OS, either stop or running. So right now my environment is again clean. There is no container, there is no OS is running. It is clean. Right? So now what exactly I'm doing here? So I am going to launch one operating system with name called OS1. Okay, from CentOS. Okay, this is the first step I'm doing. Okay, but it is manual step. So first step, let me write here. First step I did is to launch the OS from CentOS. First step. The second step is, because your intention is to inside this OS to launch Apache web server. So for Apache web server you have to install some software, httpd-y. So without asking yes or no, they will install for you. So this is second step, because your intention is to launch one program or service. Here my service is HTTPD. So that's what I'm doing here. So this is my second step. Or maybe database, maybe whatever you would be, right, want to use. So this is my second step to install HTTPD software, right? Software. This Apache web server software. This is my second step. Okay. And third step is, if you from my last classes, guys, or maybe from my IIEC Rise Linux classes, you guys know, in Apache web server is used to host the website. And for website, you have to copy your web page in a folder called where www.html. In this folder, we have to copy. Okay, so second step is done. So what to do? You have to go inside this folder and copy some web pages. Okay, so your developer has created some pages, and you take the pages from those guys and copy here. So either you create by yourself, okay, or I just do one thing. I just go to my next terminal. Okay, this is my base Red Hat, and now you can see my one OS is running. This name called OS1. And let's say your developer has created one page for you. Let me create one page called index.html. Okay, one page they create and say this page contains Vimal Daga, my name. Okay, this page your developer created, or maybe you have downloaded from GitHub, something like this. And what do? You in Docker we have a command. So if you have any page in a base system and you want to copy, in Docker we have a command called cp. And this page, this is there my base Red Hat system. I'm copying inside this OS. So you have to give OS name. But in this OS, which folder? So I would like to copy in this folder. In this folder. Why in this folder? Because it is written inside the web server. Web server read the page from this page only. The web server read web pages from this folder only. Okay, so this is a very basic command. Again, my last basic classes I've explained you, but just I explain one more time. So technically, my third step is done. So from outside world, I copy the page, whatever the created by my developer in this folder. Even though if you want to verify, you can just go to this OS. So I'm just going to this OS again. So I'm here already. In this folder, you can see this page come up and the content also come up. Okay, so this is the third step we have done. And final step is, because this is the server, right, or program. So if you want to use a program, you have to execute a program. So finally, we have to execute a program. Okay, or execute a service. Okay, execute a service. Okay, so how to execute a service? So technically, guys, if you know a little bit about the Red Hat, okay, or CentOS, we use this command to start the service. But this command, due to some reason, by default, it doesn't work in Docker. It will fail. It will fail. It doesn't support in the Docker. Okay, but behind this command, there is one program running. You can run that program to start the service. So let me show you what I mean by this. So this is my Docker. Let's forget about Docker. Let's go to my base system. So this is my Red Hat base system, not Docker. Okay, here if I try to run the command, my software installed, it will run here. There's no error come up. Okay, but this command can run directly in the Red Hat, but this system selector command, due to some reason, it doesn't support on Docker. So what to do? We can do one small trick. Okay, this command behind the scene is calling some other command. Which command they are calling? So there is one option called status. By the status, you come to know which file they're calling. So this program is running, but this systemctl behind the scene calling this file. So I'm just copying this file, and what I'm doing, okay, I'll open this file again with this file. Inside this file, what they written, right? Whenever you run systemctl behind the scene, right, they are executing this command with option called -d foreground. So what I'm doing, I'm copying this command as it is from here. Okay, so technically what I understood, even though from my last Docker class I already explained you this part, Okay, but so what I finally got, this is my Docker again. You can see with some kind of number. This is my Docker. In the Docker system.ctl command doesn't work. So, but I know behind the system.ctl they run this command. So I copy this command. Let remove the options. Options don't require. So without using the system.ctl, I can start my web server by this command. Or technically, you know what this message say? This is just a warning because I don't have a DNS right now. But this message say your Apache web service starts. Apache web service starts. So my first step is execute a program or a service. But technically, which program to execute, we don't know. We have to find some way. Database has their own command name. MySQL has its own command name. Elasticsearch has their own command name. What a program of VLC has a VLC command. Firefox a Firefox command. What a command you want to run, you can run it. But here, whatever I've done is manually. But finally, after you do all the thing manually, after doing all the 4 steps, what happened? Your environment is ready. And what this environment give you? Your site hosted. So any of the client, okay, connect to server and they can see your site. So that's what I'm doing here. So what I'm doing, I'll open my browser, think as that I am a client, and try to see this site of this OS. Before seeing the site, we need IP address. So for netting the IP address, either you can run the ifconfig command or you can see the IP from here also. So this is my IP, or you can use inspect command, you guys might know. So to see the IP. So I know the IP of this guy, or you can open one more terminal. Okay, one minute. So till here you guys might know, right? But you can open one more terminal. You can see one OS is running. All right, that I started. Okay, but if you don't know the IP address, you can run docker inspect command to find the IP. Okay, but I know by chance the IP address. So what I'll do, I'll go to my browser and I type 172.17.0.2 slash my page name. Site is working. It's not working. It will come up. Okay, so output come up. So now my website is going good, right? So it's pretty simple thing. We already done in the last class. It's not a big deal. Okay. So if you don't know the IP, you can use inspect command with the OS name. So my OS name is this one. Inspect command will give you information about this OS. Or one of the information we need is the IP address. They give you. Okay, that's all. But technically, whatever I did, it is manual thing. Or if somebody asks you to launch the same OS 100 times, so again you do all the stuff that I did one by one, one by one. I take a lot of time. Okay, so what can I do? Whatever steps I have done in this OS, I can I can create one image, and after image create, right, we can keep on doing right same thing. We can from that image I can launch hundreds of OS. Okay, so let's do the things right. So technically I want to do all the steps. So for this you have to create the image, and for the image, because your base OS is CentOS, so for this you have to use the command called from. Inside this OS I want to install this software, and because you want to install software you have to run some command, so you have to use run keyword. So this is one keyword you use. In this OS I want to copy the data from outside system inside me. So I don't have a image, right? I don't have a web pages. So web pages is there in my base OS, Red Hat. From the base OS I have to copy in this folder. So here you have to use a copy keyword. And what I want, right? I want to start my program, but only when my OS start. Right? I don't want to run my program when image is there. From the image, I have the image, and from the image when OS launch, that time I want my service to start. Otherwise, there's no reason, right? If you say if you Windows is in the DVD, obviously you don't run the program. There's no meaning to run the program if your Windows is there in your DVD or in bootable image. So when you want to launch any program, when from the image you launch the OS or you install the OS, that time I want my program to be start. So if you have this kind of requirement, then you have to use CMD. So here we have to use CMD. Means image create, but from the image, when OS launch, that time execute my services. So here guys, I introduce 4 different keyword: copy, run, from, and CMD. Okay, in this example. So let me show you how we can do. So before I do, let me terminate all the OS I have. Or I can just terminate all because I have only one. So let me terminate this OS. So this OS has been terminated. I don't want to use this. There is no OS. Okay. Now I'm going to create a new image according to my requirement. For this, it's always good practice to create a new workspace, new folder. Again, create a new Docker file with D is capital. There is no space. Docker file. There is no txt. It is just a file, Docker file. That's all. And here you use 4 keyword: from. Okay, my base OS should be CentOS. So I am referring with these steps. First is from keyword. Then inside this OS I would have run a program called yum install http-y. They will install this software inside this image. Okay, this part is done. Second step is done. Third, copy. So I want in my base system, I have some file that I would like to copy in this folder. The question is, why file is where? So technically what I'm doing, I'm open one more terminal. This is the folder where I am in, and this is the Docker file I would like to create. Let me save this. Okay. So what I want, I ask my developer, and whatever website they have created, they given to me, and I downloaded it here in one folder. For example, that folder name is website. So this is a folder name I have. I get from my developer, or I download from a GitHub, something like this. Or inside this folder, all right, developer has created website for me. Let's say they create one file called index.html with content welcome. They create one more page for me, contain vimal.html, contain my name. They create one more folder for me, contain lw.html with lw. So in this folder, they have created 3 pages, 100 pages for me. And this folder they have given to me, or I download from GitHub. Let me go up. Okay, again I'm here in this folder. What is this folder? This is the folder where I have the Docker file where I'm doing coding. Okay, but this folder I haven't created. You can think I have downloaded this folder from somewhere, but it contains my web pages. So what you want, right? Whatever the content of this folder, whatever the content of this folder, website folder, or whatever folder name would be, this folder, I want to copy. Where? Here. Why here? Because website will read from here. For where this folder is, the folder would be inside my container or inside my OS. And where this folder is there my base OS, means my Red Hat system. So if this is the case, then you have to use copy keyword. So I'm telling my copy keyword, in the current system where the program is, there's one folder called website. Slash is a good practice to write, because slash say this is the folder name. Okay, so I'm asking my copy that in my base system you have this folder, in the current directory where the Docker file is, inside this folder all the pages that you have, copy in this guy. And where this folder will be? This folder will be inside that new OS on my image. So that's what doing. So exactly the Docker copy command use, same thing they will do for us. Okay, so this is my third step. And fourth step we already discussed. We have to run one program. Which program to run? The program that will start my service. Or because we are running the service inside the Docker, then command keyword. Or because we are running the service inside the Docker, systemctl command doesn't work. So I already found one command called httpd-d foreground. How I know this command? I don't know actually. I just found either from Googling or Google search, or maybe some file I show you. But due to some way I found that I show you again here. The last I found from somewhere here. Either you can use the complete path or you can use this file command name. This okay. So I found. Let me use complete path. I found this the command we have to use. We have to use if you want web server to be start. That's all. So three keyword we have used. So if I run these three keywords, so four keywords, you will have your own personal custom image. So let me show you. So this is a folder I have. Let me run docker build. Okay. I'm going to give a new name, like this is Rise Web version 1, and from this folder. So in this folder, right, pick the Docker file, create a new image, and name is this one. That's all. So they're doing. So 4 step I have written. So they're running all the 4 steps. 1 step they're done. Second step they're downloading the software, installing for you, and third step, 4 steps. So technically, right? Technically, these 4 steps become my one new image. Now after the image create, my image name would be here Rise Web, some version name. Now from this image, it's only one-time process. One time they have to install. What are they doing? After they create this image, now from this image, how many OS you want to launch within a second? Hundreds and thousands of OS you can launch within a second. And every OS we can provide other developers for testing and some other things. All right, you can provide. So that's all. This image is successfully built and done. You can confirm Docker images and search for any image for Rise name. So yes, we can find this image. Right now we created. Now from this image, right, if you want to launch the OS, but before I launch the OS, let me show you, do you have any OS? No, because there's no OS, means there's no website running. So right now if I check any site is running, no, there is none of the site is running right now. But as soon as I launch my OS, that's what I want. As soon as I launch my OS, let's say OS 1, for which image? Rise Web version 1. So from this image, as soon as OS launch, what you will find, right? OS launch, but inside the OS you have everything, right? You have the software, your service running, you have the web page copied, right? You don't have to do anything else. One click, your OS launch. See here, one click, your OS will launch, and this is the message again you get: OS is launched, and the OS is running behind the scene. You don't have to do anything. Again, you go to the client and refresh your page. You can see the page. And that time I created 3 pages here. So if you go for Vimal HTML also, you can see this page also. This page also there. Okay, right? It's fantastic one. Okay, and if you do Control C, your OS stops. OS stops. And because OS stop, if you try to refresh, obviously you won't be able to connect. They're connecting, they will fail after some time. Okay, and one more small thing, this command you already know, because normally when you would like to run your OS, you don't want to run your OS in the foreground. It's called foreground. They keep on running, right? And if anything running in the foreground, you can't run further commands. So what can I do at the time of launching? Let me launch one more OS called 2. I can launch my OS in the background. It's called demonize or to call detach. So enter. So my OS is running in the background. I get my next terminal. I can some other command. I can launch some other OS, but you can see my OS is running in the background. It's running in the background. But doesn't matter wherever my OS is running. My client try to connect. They can connect. So my client is trying to connect. They can connect. Right? They can connect this OS. Okay. So this is the meaning of D command. You guys know daemon. But you guys also know one more thing. Okay, the thing is, because this is the web server, right? This is the web server. Okay, and we know if any server, either web server or app server or mail server, normally client from outside world they connect. Okay, before, if the client want to connect to the outside world, right? So what we have to do, so from our last class, you guys know the concept called patting. We have to do patting. Okay, so what to do in the patting, right? We have to write something like this. Okay, so let me launch one more program here. Okay, and we have to write p, small p, and say inside this os, what are the os we are running? One program is running, and because this program is web server, so program is running on the port number 80. Of it's a mail server, they're running on port number 25. Program is telnet, they're running port number 23. Depend which kind of program you're running. Okay, because this is your program, you normally know the port number. So you're right, inside this os, I'm going to run program called 80, running on the port number 80. Because my Docker, because of security reason, okay, when I launch my os from the Docker, because of security reason, they are isolated. Or because they are isolated, so outside world, they want to connect, they can't connect. But if you want that this os can be connected to the outside world, so what you have to do, you have to expose this guy. And for exposing, right, what you have to do, you ask your client to come on the IP of my base os. So my base os is Red Hat. Use the base os IP, use the base os port number. And which port number to use? You can give any port number. For example, let's say 80, 89, any port. So guys, I'm not again explaining this topic, because this topic I explained one dedicated class I have taken in this topic. I just want to recall this part we have done. So if you do this, your new OS, let's say OS number 3 launch, but in the same time, this OS launch, but in the same time, all right, anybody from outside world connect to this OS in their IP address in the port number 80. They can see the site. But how the outsider will come to this guy? They come to this OS with the IP of your base Red Hat, where the OS Docker is running, and on the port number 8089. So now in my case, if I go to my Windows, my other system, my laptop, other laptop, and if I write 192.168.162 and the port number of my number that I given you 8089, I can see the site. Or maybe I have created one more page there, lw.linuxroot.html. All right. Slash lw.html. I can see it. So it's working fine, great, right? Why? Because I exposed. But in this whole scenario, you guys know already this concept, but I'm just trying to give you a better way. Okay, so in this concept, the only challenge is, right, this image is by chance created by us. This image is by chance created by us. So we know inside this OS, Apache web service running. And we know inside this OS, Apache web server running on the port number 80. That is the reason we can give the name number. This number is anything we can give. This is my base OS number. I can give anything. Okay, but this number we should know. And why you know? Because you know about this image. But maybe you can think this image not created by me, you. It is downloaded from somewhere else, and you know how to launch this image OS, but you don't know inside this OS what a service somebody has provided you. They are running on which port number 80, 25, 80, 80. We don't know. Okay, so what these guy has to do, the guy who have created this image, they are the one, they have to tell us, because they are the one who created, right? So they have to do one more step here, fifth step, and they have to tell, I have created my service, right? And my service, because I am the one who created, so I can choose any of my other port also, I can change my port also, right? So I am running this service on port number 80. So this is a port I am giving you, I'm exposing you. Okay, so it's always good practice, the guy who create the image, they always tell which port number they are working on. Okay, and this is the fifth step. Again, for this we have to keyword call expose keyword you have to use. Okay, so that's what I'm doing here. So rather than I use this command, I use this command. Okay, what I'm doing, I'll go to my Docker file. I'm the creator of this image, or the developer of this image. I write one more thing here. I'm telling my this program is running on port number 80, 81, 25, whatever the is working on. So my this web server is working on this port, or maybe in your case it is working on a different port. You can tell here. Okay, so this is good practice. So what is benefit of this number exposing? I'll tell you in a minute. Okay, so let me write this expose one keyword. Okay, and let me again do docker build right, t um, rise web, just give me version 2 and this folder. Or because you are already in this folder, so you can use dot also. So in the Linux, dot means right that retrieve the Docker file from the current folder. Because I am already in the current folder, either give the complete path or you can use the dot. Both the way it work. Okay, so that's all. The image created. Let me confirm this image created, not Docker images rise version 2 created. But the good thing about this image is now, right now I don't have any OS running. It is running, so let me delete everything to clean the environment. Docker rmf docker ps -a-q. So I'm guys, I'm just removing my OS. I'm not removing the image. If you want to remove the image, command is rmi. So I'm just removing my old OS running, so I can show you very freshly how it's working. Okay, so I have this image that we have created. Now good thing about this image is now from this image, if I launch new OS with some name, let's say OS 1. Okay, image name is rise web v2. Okay, the good thing is, right, let's say this image is not created by you, but you are using somebody image. Okay, so you launch it. D means put in the background. Run means launch a new OS. This is the OS name. But you know this OS has some service, and normally 99.99% whatever image you use in Docker world always has some service, maybe database service and some other service, and all the service normally have the port number. Okay, so technically, but you don't know the port number, which port number this service is using inside this OS, my web server. But you want to expose this service. So here, because you don't know the port number, so you can use hyphen capital P option. That was small p, here capital P. Capital P is very smart. They go inside this image, they retrieve the expose keyword that I write here there, and they come to know, okay, they say I know in this OS they are running some service, and that service is running on the port number 80. Now without you go and find, capital P will find for you, and they launch the OS. And now if you're on the docker ps command, what you come to know, right, automatic your service been exposed to the outside world. See here, automatically find 80 port, and randomly, because 8089 is what the random port we have given, randomly they find the one port in your system, whatever available they give to you. That's all. So this program become more intelligent. Okay, so we can do in this way, but this concept will only work if we have in this image is somebody use expose keyword, and I can provide this port 32768. It will be any next time might be different, 32768. And if my client use this port 32768, they can connect the site working fine, right? So this is one thing. But this concept is very important because right now I'm doing everything in the Docker. I'm launching this OS from the Docker. But in the real world, in the real world, right, if you want to launch any OS from the image, okay, we don't normally use Docker. We use Kubernetes. We use OpenShift and these kind of tools. Okay, and this tool automatically launch the OS for you from the image. And after the launch, these tools will also expose the OS to outside world. And for exposing, they don't know which port to use. So here internally they use expose keyword. Right? They ask your image, your port. Just tell me on which port your service is running. So technically, finally, if you would like to work on this kind of high-end code technologies, right, if you have the image without the expose keyword, it won't work in Kubernetes OpenShift. And there's a guys very small thing, because a lot of guys think there's no good great thing I found in this expose keyword. Maybe by this example you might not see a great thing, but right, if you create one image doing some service, database service or MySQL or mail service, if you don't expose in the Docker, you can use small p and expose for outside world. But in the Kubernetes and this is called bigger environment, the tool is very intelligent, very automated tools, right? There, they are highly relied on expose keyword. If your image doesn't has the expose keyword, it won't work. It won't work. So it's very critical. There's easy reason. Whatever image you download from Docker Hub, all right, they always has the expose keyword. How you can confirm? Let me show you. For example, this is the image we have created. Okay, so if you want to see the history of the image, how it's been created, you can use history command. You can tell rise web version 2. So you can take see the history. So anybody can see the history of my image who have this image, how I created this image. You can see somebody write some cmd with some command stdpd, then the copy, then the install, right, then the expose. So anybody can see my history of my image. Okay, similarly, I have downloaded one image from the Docker Hub stdpd. This is one image I downloaded, and this image I downloaded from some other community. So if you go to Docker Hub and search for this image called HTTPD or MySQL. So from here I downloaded this. Okay, and now if you see the history of this guy, so I don't know who has created this, but if you see the history of this guy, what you come to know, right? This guy has also used an expose keyword. Okay, that is a reason. That is a reason. If I use this image and run it with DIT, right? I can use capital P. Okay, I can capital B. I just want to give some OS name. You can use it. OS for let's say 5. Okay, it launches for you. And internally, they go and find your port number and they map to this port. It's called bind. They bind to this port or pad to this port and give this number. But again, because we know Docker a lot, so we are doing everything for Docker. But the other automation tool or clustering tool or advanced tool or orchestration tool, cloud tool, right? They don't run this command. They enter run some other program, and then they go to the history of these guys and find the expose keyword to find the things. Okay, so these are the guys main keyword I explain to you. But the other keyword also, you just go to the docker file docker file commands and documents. All right, there's some more keywords you can find. Some of the scenarios we use those keywords. Okay, you can see. So this is a command I've given you, docker build, all the things. So you can find some of more keywords over here. But what a keyword I given you, run cmd from expose. These are main keywords. Okay, we always use this keyword. Otherwise, there's some other keywords also. Let me tell you one more last keyword for today. Right, like this is again one more great scenario, right? So let's say this is the image we have created. Okay, this is the image we have created, not this one. Let's say Python one, right? So one image we have created of the Python was the name I've given, rise actually. So this image we have created, and if you see the history of this image, history of this rise version 2, what it is written, whenever you launch this image, in this image we use cmd command, and then cmd we write Python. So as soon as you launch this image, okay, they always run CMD. They always run Python. Let me show you one more time. So as soon as you launch this image, run, they launch Python. Okay, it doesn't show you because I have to use int. So they launch Python. Okay, but due to any reason, right, you want to override Python for this launching. So what I want at this time, I'm launching new OS. But I don't want. I know in the they have CMD. They have CMD command variable, and that launch Python always. But again, from this image, I want to launch one more OS. Let's say this OS name is called new OS one. But what I want in this OS, right? They don't launch Python. They launch other program. They run another program. It will be any program. Let's say date command. Date is also program. Okay. So you know what happened? Even though we have we have write CMD, CMD, uh, but CMD has one interesting fact, right? On the fly, this is called runtime. So at the time of launching the OS, or you can say at the time of runtime, you can replace or override the CMD value by giving the command name, program name in the last. And now what you see, guys, this OS will launch. Inside this OS, they run the date command, and as soon as date command run, your OS terminate. See here, they run the date command and your OS terminate. You come out. But this OS was launched. How I know? Docker PSFNA. So my OS was new OS one. New OS one. It was launched. And which command they run? Rather than Python, they run that. So the good thing about the CMD is right on the fly. If you think at that particular time or runtime, I would like to replace with other command, you can replace it. Okay, this is one thing. Okay, now we can utilize this power for do something, right? And how we can utilize this power? You can utilize this power with the one more uh, concept. But let me show you one more. Uh, let's create one more image, so I can show one more interesting keyword. Let's say this is W2, and I'm going to create one more image here with DockerFile. So this is the guy, one more image I'm going to create inside a new folder, inside a new workspace. And I'm picking this folder image from CentOS. And here I'm using one CMD. And what CMD doing? CMD will run the cat command and they read some file. Let's say we have one file called etc password. There's one file is there in my Linux. So I'm just trying to read one file. So what happened? As soon as I create this image, they set the CMD, this command. Okay, so this is the command in the Linux, and the meaning of this command is right. Cat is to read the file, and this is one of the file is there in my system that I'm reading. So there's nothing special about this file. Okay, that's all. Very simple. Docker file I create, and let me build this. Build -t. Let's say this is zzv1 and dot. Let's build very faster. Okay, now what happened? Now from this image, if I'm running this image, what happened? As soon as I run this image, they launch OS. But in this OS, they only run one command, cat command. Or what cat command do? They read the file. Or they read the file, what a file name I've given. So they read that file. Okay. So as soon as I run, they all they launch the OS, and after they launch the OS, they read this file. Okay. But technically, if you talk about this image, right, this image is only meant to read the file. So guys, it's very interesting. You know what? It is something like this. You install your OS in the laptop, Windows. As soon as the Windows start, you read the file, and that's all. Your Windows stops. So one OS is just for read the file, and there's the power of the Docker, right? You can create hundreds of Docker images for multiple things. But here, right, you want to read the file, launch the OS, they read the file. The only challenge is whenever you use this image to launch the OS, they always read this file. It always read this file. Okay. So what I want my image to be customized. I want my image to be customized. What I mean by this. So I want in this image, okay, maybe I know the main command to read is cat. Okay, cat. But this is the file name. So I want my user who use this image, they can use any file name. Maybe pastel file, hello file, dot code.py file, php file. Okay, so what I want whenever I run my program, I would like to give my customer or the user an option to tell their file name, which file name they want to read. Okay, but for reading, cat command is fixed. So you want as soon as your program run, your cat command always run. Okay, this part I want always run, and this part I want customer or user can give on the fly on the runtime. So here guys, the role of entry point come in play. Entry point, and here I can give with CMD. Okay, so what is mean by entry point? Entry point is like just like CMD. So what happened from this image? Okay, whenever you launch the OS, they always run the cat command. Cat is one of the command lines to read file. But if my customer or user doesn't give the file name, they use this file name to read. Because this file name I put in the CMD, it means because CMD is customizable, right? On the real time, they can change the file name, or this called they can change the argument. So let me save this. This is the file I have. Let me build one more time with version 2. Okay. Now from here, let me launch one more image. Run v2. Now in this image, we have two keywords. One is entry point, one is CMD. Entry point say when you run this OS, means from this image when you launch the OS, I always run one command called cat command. There's a fix I always run. Okay, but because you are not giving any file name, so I will ask my file name from my CMD. From my CMD. See here. So same output will come up. It shouldn't take a lot of time, right? Why it take a lot of time? Because there's small issue. They also hang up. You can go to new term and remove it. But the one issue is I write the wrong syntax. Okay, so in the entry point, the command that you give, you always write between a square bracket and double brackets. So even though if you search in DockerFile, wherever you find entry point or search Docker entry point, right? Example, you will see we always write our code between double quotes and the square bracket, right? CMD we can write directly, okay, but entry point normally we have to write between the double quotes. So we can see some more examples here. So I think this was the issue, maybe, I believe. Let's say, let's see. So let me build, let's say ZZ v3 version dot, they created, and now launch this guy ZZ v3. So as soon as I launch, this is image name, right? And as soon as I launch from this image, they read the file and they show me. Okay, 1 minute. Okay, uh, what happened? Invalid option. What, let me write the full path. Okay, guys, 1 minute. Let me check. Right, I think we have to give full path also. Just give me a minute, please. Let me check. Then I'll update you again. What happened? Hmm, this syntax, right? Entry point. Uh, Same thing you have to write here. And CMD also. Right. Build. Run. Z3. Yeah. So you have to use this syntax. You have to use this syntax. So write your command name. Even though I don't think so, you write full path. Let me check to update you. Full path is always good. What is command full path? Always write. It's always good practice. But let me check without full path also it is working or not. Yeah, it is working, right? So this is the final syntax, right? So always use CMD and the entry point. Even though if you use only CMD, also use in the same way. Okay. So in the double quotes with the square bracket. This is the syntax you have to use. Okay. So finally, what happened? Let me show the final demo again. So this is the way also to make your you know code more dynamic. Okay. So let me run again. 1 minute. So as soon as I run, okay, my run will launch this image. Even though if you want to use IT also, you can use it. But even though I don't require IT because I don't want to go inside this OS. So without IT also work. Okay. So when I launch this image, it become OS. But as soon as OS launch, they see entry point, they run this command. Or this command would be cat command, your Python code, Node.js code, web server, any of the program you can write here. Or maybe wget command, curl command to see the site, download the page, backup, okay, or maybe testing program, okay. But if you want to download some page, so what you want every time you want to change the URL, so you can put one common URL here, okay, or maybe put some have an edge options to take the help, or every time. Right now, if you see, because I won't give you any file name here, so which file they read, the file name that I put in the CMD. But next time if you again check this file, next time if I want to read other file, for example, I have one more file here, it's called set of file. So this time they will read a different file. See here, the different file they read. Okay, and if I run without shadow or without any files, they will read this file. So this is a different file they read. Okay, so technically what is happening, so this is a great example actually altogether. So you can use some command called, let's say, wget command to download, or curl command to download to see the site, or tar command to backup. Okay, and here you can pass some. So let me fastly build this. All right, so here I use curl command. Yeah, but only one small thing is, like, whatever command you are running, it should be inside this OS. Okay, so this cat command should be there inside this OS. So inside this OS, if there is no curl command, it won't work. So first you have to install first curl command, then it will work. For example, let me show you very faster if I can do this example with gedit. So what I'm doing, I'm taking CentOS, then I'm using run command to install the curl command. So in this OS we have the curl command, then entry point would be curl. Okay, and CMD would be, I don't know which URL my user want to use, so I can use H. So H is the one who give me the help. Okay, that's all. Okay, so now what happened, right? Now if anybody use this OS, let me build this OS, they're installing the curl. Only once they have to install, right? Now this OS is very dynamic OS, right? Now whenever you launch this OS, right, every time they ask you from which site, which web page you want to access, which site you want to access, accordingly they download for you, because curl is to access the website. So depend which program. Maybe you can write a Python program here. Okay, guys, right now curl command doesn't install. Let me check one more time. I don't, maybe I don't have the curl there, I don't know. So they're downloading curl. then then they do it for you. Okay, so that's one. Let me check, does I have curl also or not. If you don't have a curl, you can use other software example. 1 minute, let me check, does I have the curl or not. My Red Hat, I have the curl, but CentOS, they are downloading. If they have, they will download, otherwise they fail. So they're trying to download. But you get the idea, right? You get the idea. So typically is always great to merge these two options, entry point with CMD, right? Normally in the entry point, we always give your program name, and CMD we always give the arguments of the program. One of the simplest example is, very simplest example is this one. So ls is a command, or ls have an a as argument, l is the argument. So we can tell ls is my entry point, and these would be one of my CMD. And my user has options to change on the fly their arguments. That's what. So now this image has been created. Now good thing about this image is, when I launch this image, okay, because I'm not giving anything. So what happened? They run this command with option called h. H is a normal command in normally to ask for the help. So as we run the curl command, run with the help, right? That's all. It means my user come to know. It means this image is is for is for curl, right? Now in the curl you want to pass some URL, let's say http://www.google.com. So they just curl this site and download the page. They curl and download this page for you. So they're downloading this page and access is first for you. Either this page or some other pages that they are downloading, you can see here. Or maybe they download, it's not able to resolve because of maybe the networking, but you can see it is working. Or maybe very faster to check this demo, what I'm doing, I'm launching one website from my HTTP program. This is one website I launched, and in this website I have one page. Let me check the IP of this OS. How to find the IP? Inspect of this OS. This OS has the name, this one. This is the IP 5. Okay, and you want to see the IP data of this website, you can use curl command either manually, it work, or what can you do, you can launch the complete OS for this. And right here I have one site running on IP5. If they have network connectivity, network connectivity, you can get the IP. See here, it's come output come up, right? So it's so awesome, right? If you try to understand, just for curl or download the page, I am launching you can't possible, right? If I ask you the cloud world or virtual world that please launch one OS, and you ask me why, I say launch this OS. After launch this OS, download one page, and then shut down this OS, and after shut down this OS, terminate this OS. Okay, so you feel like I'm so silly because this is a for just for downloading, I'm asking to launch the complete site or complete OS. So in the virtual world, nobody can do this, right? But in the Docker world, it's so fast. So how can I do? I'm going to launch one site. Let's say there is a name called ZZ, or maybe my web 1 or 2. Okay, so in this OS I launch. Okay, then I launch from this image, this is my OS name, and they download from this guy. After download, my OS shut down. How you know OS shut down? Your OS is shut down, right? There's no OS running with this name, and they shut down. So it's so quick, so fast. The OS shut down. Where it is? It is shut down here. It is shut down. Even though you can also do one more thing, okay? Because your requirement is to just launch this OS, okay? So from this image, I launch this OS. This OS download my site from this guy. After download, I don't need this OS, so you can use have ARM option. So it's so fast, so quick, guys. I don't know if you have understood this part or not, right? You know what they're doing, right? From this OS, first they install this OS. So from this image, they install this OS. Inside this OS, internally they run the curl command and download the site from here. After they download, they show you here. Then they terminate this OS, right? So it's so quick, all right, and it is working great. But you know what? Here I created my own personal requirement. This is my own personal. You can see it is also removed from here. There's no name W111 come up, right? So so this is my personal. So this is a custom requirement, right? And for any custom requirement, because in the real world, in the production world, in the industry world, right, you you have to create your own custom requirement. Whatever you need, it is not available in Docker Hub or somewhere, right? You want to do machine learning, deep learning, Jenkins, anything, testing system, right? You know your requirement, and because you know your requirement, you have to create your own image. And for creating the own image, Docker file is always the great. So entry point is again the one great keyword. CMD, empty point run. These are the very important keywords we have to use. So guys, this is important class. So which whatever domain you want to go, and CI/CD, Jenkins, Kubernetes, OpenShift, cloud also have a container services, right? Dockerfile is the need. It is not because Dockerfile, even though we have some more technology available, Podman, Cryo, but this image is common for everybody. So whatever technology you use, the image is same. They support the same image. They use the same concept. They use the same Dockerfile concept to create the image. So whatever whatever the content technology product you use, right? Image creation, image concept would be exactly the same. That's what, guys. So it's been a long class. So what I want now, if you have any queries, right? Let me uh, uh, start. So what I'm doing, guys, right now, I'll just open your chat box. If you have any query till yet, but if you understood, I have explained you only 5 keywords, but but I explain you with the real use cases, and this real use case is very important. Okay, you should know where to use what, and this was a confusion. Even though very lot of guys say there's no meaning of the expose, there's no meaning of the expose, why we need it, but I try to explain you where to use expose. Okay, so that's what I have done here. So guys, try to ask me only those questions that's related to Docker. Why Docker is fast? Maybe Raju, I will try to take one more class in upcoming to explain you why the Docker is fast. I haven't explained till yet. Okay, Nagaranjan, almost all the major topic that we require in Docker certified associate exam is covered. Not yet. This because this training is not about the Docker associate examination, but 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 this keywords is very important. But I explain you. But they also ask you some more thing about Swarm and all the things. Maybe I'll try in the upcoming class in the Rise. I will explain you about Swarm also. But almost all the major concept I have explained you. You can do your own study, and then you can appear for the examination. Okay, why the difference between CMD and the run, guys? This is a very great question. We have to understood, right? The core difference in the CMD and the run is, let me again share my screen. The core difference between the CMD and the run is, okay. Um, and this is a very common conceptual issue we have. uh, Run and CMD. Okay, so one of the example I use is in the run I use command called yum install stdpd, or CMD I use one command like say cat command. Okay, so what a different is, so run will run at the time of build, CMD will run at the time of runtime. What I mean by this, let me show you with very small demo. Okay, so this is my um, um, let me create very faster one more environment, and this is very common questions being asked, or also very common conceptual we normally confused. Okay, so let's say I'm going to create my one more OS from base OS CentOS, and I run here date command. Okay, and I use CMD cal command. Okay, or maybe let's say cat command, cat with some file. So what is difference? Okay, if you this is the just a script, right? You have to build it. How to build? We build hyphen t some name of the image with dot. So what happened, guys, when you build or run this script, it's called build time. And in build time, right, they always run the run command. So you see, guys, they run the run command, they're running, and internally they show the about output date command. But here, guys, because whatever command you write in the front of run, they run it, and whatever run command do changes, they update this image. Right now date command is not doing any changes, but maybe here you create one file, you copy one file, you start some services, install some software, whatever you do, okay, they update in this image, and that changes they store in our new image. But if you notice here in CMD, I asked to read the file, but they haven't run it, they haven't stored the file, because CMD they update inside the image as a metadata, as in the history, and the CMD only run when you run the Docker. So when you launch the Docker, okay, so at the run, this called runtime. This time they go to history and they ask, "Do you have any CMD?" Yes. That time they run the command. They run the command. So you can see they read this file for you. So finally, run means at the time of runtime, sorry, at the time of build time, or running the code, or running the script, they run that commands. And whatever the command change, they update in your image, your new image. In the CMD, they run a runtime. Means at the time of Docker run command, whatever command I write here, they run it for you. So there's the big difference, or there's the only difference actually, right? So any other queries, guys, if you have? Yes, guys, we can put our PHP page also in the external folder, but for this we have to first install PHP software. You can also create Oracle also, guys. For Oracle, whatever the step you normally do in the Oracle installation in other environment, same step you can do here. So install the Oracle, set up the Aura tab file or other things, Oracle services. So technically, I just give you the way and approach. Everybody over here maybe in the different environment, right? So whatever environment you guys work on, technology you work on, so what are steps you follow in your environment, you can do the same way. You can use the run command and run all the commands. Okay, yes, we can launch the graphical also inside the Docker. This is one of the tasks I have given to you. Just try by yourself. I think somebody might have post some answer in the rise page. Just go and get the answer. Or maybe if I take one more class where I explain you why Docker is fast, maybe that time I will take the topic. Okay, so So no guys, we can't do any condition statement Docker file, but yeah, we can do, because here we are running the commands. So after the run, we are running the commands. So run, uh, after the run, because we are writing the command, so we can use shell scripting. So we can use all the shell scripting keyword. On the shell scripting, we have if, else, for loop. So in that way, so Docker doesn't have if or else, but we can use shell scripting after the run to do your scripting, conditions, concepts. So Dockerfile is not actually scripting language. They have their own keyword just to tell what they have to do. That's all. So there is not pure typical keywords, typical scripting language. And guys, those guys who doesn't get the chat box right now, so do one thing: refresh your page or go back, come in the same URL. You will see your chat box come up. How to launch Docker inside Docker. Again, for this, I the exact same concept that I used in a web server. Okay, so install the Docker and just go to systemctl intel file of Docker. Then you come to know what Docker intel command they use. Okay. Plus, there is one more concept of Docker socket. You have to mount the socket also. Okay. So just try this approach I'm just giving to you, but it will work. We have tested multiple time. It will work. Okay. So just try it. Maybe if I take one more class, I will show you in the next class this demo. Somebody say last time you used different location. It depend upon the version of the Apache. Okay, so the because this Apache I am configuring, and by default in Apache server, the location of web page is where WSTML. Okay, but if you're taking the reference of my class in my DevOps class, right? There I use HTTPD image, and that image is created by somebody else. So they have changed the location to USR local Apache to HTTP docs. Okay, so depend which image you are using. Okay, if you create your own image, so by default, normally the by default location is where www.html. But question would be, you can think in this way: how we can find what is the location of our folder, where to keep our image, where to keep the image in where WHTML or htdocs. How I come to know. So for this, if you go through my web server classes in my RSSA training, there I explain, right, how to change the folder. There I explain you where this folder location we update. So there's some internal configuration file of Apache. You just go to that file, and you can change by yourself. Or from go to the file, you can also come to know what is the default location. Okay, so don't remember this. Anybody can change. So it is good way is to find out what the way and approach how to find the location. So why Docker is fast, we'll discuss in the coming class. Are you trying new batch for no, no guys, there will be no further batch for DevOps AL assembly lines, or there will no further batch for machine learning OOps, MLOps, right? So they will no batch. So MLOps batch is going to be complete soon. DevOps batch we already started, but there will no further batch for especially for DevOps assembly line. How to mount volume with Dockerfile. So Arix, there is one more keyword called volume keyword. So the same way that I use expose, we have one more keyword called volume keyword you can use. So you can't mount, but you can use volume keyword. Okay, and the same concept I explain you, with the hyphen capital P. Something same concept we have in the volume also. So as you can use some volume options in the Docker command, run command, they automate know where to mount. But I suggest you just go and look at the keyword called volume keyword. Suraj, yes, so, you guys are almost capable of giving Docker Associate certification. I'm again repeating. I created this program as a standard program, mainly that is normally we use in the corporate world. Docker Associate might have some more topic, but almost topic has been covered here. Okay, covered here. uh, any other topic left, you can now you have sufficient knowledge, you can learn by yourself. Even though I might try to take some more classes so that topics also be covered in this training. So I'll see how can I do it, but I don't want you wait for me. You just try to learn by yourself if any other topic that then in the that associate examination. Okay. Attendance process, you guys know in the initial class I updated already. Attendance process, so if you want to know the attendance process, so go to my sixth class, means last class of Docker. There I explain you the attendance. Okay, even though technically in Franklin saying we have already concluded my Docker class, right? This is the extra class or bonus class I pick just to give some more knowledge. Okay, but technically, the Docker training in the IIEC we already closed in my last class. Okay, and the process of attendance is already done, and the process of project is also done. And I think we have already start processing for distributing the certificates. Okay, so this class I have uh, mm, uh, I took just to give some more extra knowledge in the Docker world. So anybody want to go some advanced thing, maybe Kubernetes or OpenShift, maybe CI/CD, DevOps, or maybe purely in Docker they can use somewhere. Okay, so you can take it as a task right now. Whatever technology you guys are working on, maybe Oracle, maybe Logstack, or maybe Splunk, maybe machine learning, deep learning. So create your own image, right, and use that image, or maybe create your own image and upload in the Docker Hub. And how to upload in Docker Hub, in one of the class I show you the way how to upload in Docker Hub. Okay, so use those thing. Okay, Suraj, I think for DevOps assembly line training we have closed the registration for public world, but I think it is still open for MLOps guys. So if you are in the MLOps training, your registration is still open. Why? Because till now we are doing a common classes. So because nobody of the MLOps guys missed anything, so that is the reason we have still open the registration only for MLOps students, but it is closed for publicly. Otherwise, any doubts if you have, you can contact to my team or you can contact to Preeti ma'am. So that's all, guys. So I hope you understood the core principle ideas, core concepts of the Docker file. Okay, that's all. And guys, one more question we have: a Docker file with it, guys, in the Docker Compose we have one keyword for include Docker file. So if you search the keyword in the Docker Compose to include Docker file, you can find. So we have one keyword available. Okay, so that's all, guys, for this part, and we'll soon start some more new topic, some more new concept will continue. Okay, bye, take care, guys, see you, all the best.